A cornfield looks green to a standard camera. A ResNet vision model declares it healthy, but beneath the canopy, photosynthesis has already collapsed. The shape of a dying crop is a post-mortem indicator. By the time visible chloroses arrives, the yield is gone, 10 to 15 days too late. Veriprajna posits a foundational correction. Maps are not pictures, they are data. The era of digital farming built on JPEG cameras and ResNet vision models is over. The future belongs to spectral intelligence, to deep architectures that ingest 200 bands of radiometric reflectance, not 3 buckets of color. Stop looking at pixels. Start reading the spectrum. The standard computer vision stack is mathematically incapable of seeing plant chemistry. A 2D convolutional network aggregates over channels in its very first layer. 3 correlated bands collapse into one feature map. 200 bands collapse into the same flat shadow. The NDVI, near-infrared minus red over near-infrared plus red, saturates in dense canopies and confuses nitrogen deficiency with drought. ImageNet transfer learning fails 3 ways at once. Domain shift, channel mismatch, feature irrelevance. The architecture is looking for the wrong thing in the wrong place using the wrong math. A wrapper consultancy built on these models cannot parse a 200-band hypercube. The Veriprajna stack treats the spectrum as a first-class citizen. A hyperspectral pixel is not 3 numbers, it is a vector of 200 or more. From 400 to 700 nanometers, chlorophyll absorbs. From 680 to 750 nanometers, the red edge forms a sharp reflectance cliff. From 750 to 1300 nanometers, the mesophyll scatters. When the plant stresses, the inflection point of that cliff drifts toward the blue, measurable in nanometers, invisible to a 3-channel camera. Layer 1 is a 3D convolutional network. The kernel has 3 dimensions: height, width, and spectral depth. It slides not just across the image, but through the spectrum, preserving every interband correlation that defines a material signature. Layer 2 is a spectral-spatial transformer. Each pixel becomes a sequence of 200 spectral tokens. Self-attention dynamically weighs which bands matter, connecting a red edge feature at 700 nanometers to a water absorption well at 1400. The model attends across distances no convolutional kernel can span. Layer 3 is a masked autoencoder, hide entire spectral regions and force the network to reconstruct them. The model learns plant physics from raw radiance. Without a single human label, the field numbers carry the argument. Descartes Labs forecast U.S. corn production from spectral signatures of millions of acres daily. In early August, weeks before the USDA's official survey could match, the model's error fell to 2.37%. Across an 11-year backtest, the spectral forecast beat the USDA at every point in the growing season. Planet Labs paired its constellation with Organic Valley to model forage biomass from reflectance. Pasture utilization climbed 20%. Gamma flew hyperspectral drones over Brazilian sugarcane. The cameras resolved the spectral signature of nematode infestation that RGB drones missed entirely. Disease recognition benchmarks now report 92 to 95% accuracy at the early stage, against 85 to 90% for RGB models that only catch the late stage. Self-supervised pre-training has matched fully labeled baselines at over 92% accuracy, and the latency advantage is the headline. 7 to 14 days pre-symptomatic detection, while visible imaging arrives 10 to 15 days too late. The strategic line is simple. AI-based early disease detection prevents yield losses of 15 to 40%. Return on the detection technology often exceeds 150%. Variable rate technology, driven by spectral nitrogen maps, cuts fertilizer application by 10% across an enterprise portfolio. SWIR-driven irrigation cuts water usage 20 to 25%. The math is a board-level decision, not a procurement one. Enterprises that stay on standard computer vision will drown in data while starving for insight. They will see the field, but they will miss the harvest. This is what we mean by deep AI, not a wrapper around a generic vision API, a neural architecture engineered for the physics of the data itself. The 18-page brief lays out the full architecture. Read it, Building True Intelligence.